All right, let's pull back the curtain on a secret story, one that plays out in just the first few seconds of your computer's life. It's this really cool tale of incredible constraints, clever handoffs, and an unsung hero called the bootloader.
You know that feeling, right? You press the button and a moment later there's your desktop. It feels almost instant. But in that tiny gap, there's this complex and absolutely critical sequence of events unfolding. And that's exactly what we're going to dive into.
So at the very heart of that startup sequence is this one piece of software, the bootloader. You can think of it as the ignition key for your computer. Its entire job is to wake the system up and hand control over to your main operating system, whether that's Windows, Mac OS, or Linux. So why do we even need this thing? I mean, why is a bootloader even necessary? Well, it all comes down to what we can call the blank slate problem. When your computer powers on, it's basically this incredibly powerful machine with absolutely no idea what to do next. Okay, so here's the core of that problem. Your operating system, all your files, they live on your hard drive, which is non-volatile. It remembers everything, even when the power is off. But the computer's actual thinking space, its RAM, is volatile. That means every single time you power down, it gets wiped completely clean, a total blank slate. And that right there, that creates this classic chicken and egg problem. The computer needs to get the operating system from its permanent storage into its empty working memory. But how can it do that if its memory is blank and has no instructions? That's where the bootloader steps in.
The solution starts with this tiny initial spark. See, the very first piece of software that runs isn't the whole bootloader, but just this minuscule first stage. It's designed to do just one thing: get the ball rolling.
It's kind of like a relay race. When you hit the power button, the computer's firmware, the BIOS or the newer UEFI, wakes up. It does a quick check of your hardware, finds a drive it can boot from, and then loads that tiny first-stage bootloader into memory. It's effectively passing the baton.
And when I say tiny, I mean it's almost unbelievably tiny. On older systems that use something called a master boot record, or MBR, this first critical program had to squeeze into just 446 bytes. We're not talking kilobytes or megabytes here, we're talking bytes.
The total space available in that special spot on the drive, the MBR, was only 512 bytes. And a big chunk of that was already reserved for the partition table, the map that tells the computer how the disk is organized. That left just this tiny, tiny sliver for the actual boot code. To put that in perspective, 446 bytes is less information than you can fit in a single modern-day tweet. Seriously. Imagine trying to write a program that can find and start an entire operating system using less text than a short social media post. It's just an incredible feat of engineering.
Okay, so that tiny first stage has done its one job. Now what? Well, now it's time for the second stage handoff, and this is where the real power begins.
This is the second leg of our relay race. The first stage bootloader's only goal is to find and load the second stage bootloader. This concept is called chain loading, where each program is just smart enough to load the next, more complex one in the chain. And this second stage is where all the cool stuff happens. It's not stuck in a few hundred bytes anymore. This is the program that can give you those interactive menus, like the grub menu on Linux systems. It's what lets you choose between Windows and Linux on the same computer, or boot into safe mode when you need to fix something. Its final and most important job is to load the kernel, the very core of your entire operating system. Now, you should know, this process has definitely evolved. The old BIOS method really relied on that tiny MBR program. But modern computers use UEFI firmware, which is way more sophisticated. It can handle massive hard drives, it's more secure, and it loads a full bootloader application directly from a special, dedicated partition on your drive. And hey, this whole booting concept, it's not just for your laptop or your desktop. It is a fundamental principle that applies to pretty much every piece of smart technology you own. I mean, your PC has that flexible, multi-stage process we've been talking about. But an embedded device like your GPS or your smart TV needs to be instant on. Its software is usually stored right in ROM or flash memory. And some computers don't even have an operating system on them at all. They can boot over a network, pulling their OS from a central server every time they start. Okay, so this is all some fascinating technical detail. But why does it matter to you? How does this invisible process actually connect to your day-to-day experience of using a computer?
Well, I guarantee you've seen a bootloader in action. If you've ever set up a computer to dual boot between Windows and Linux, that black screen with the white text that asks you which one to load? Yep, that's the bootloader. Specifically, a boot manager like Grub. giving you a choice.
Or what about this one? Ever had a problem with Windows and had to mash a key during startup to get to that advanced options menu so you could select safe mode? That menu is also presented by a bootloader, in this case the Windows Boot Manager. Turns out you've been interacting with them all along.
So yeah, whenever a bootloader gives you those kinds of choices, it's often called a boot manager. It's the same fundamental technology, just with an added layer of user interaction. It's like a gatekeeper that lets you decide which path your computer is going to take.
So from the moment you press that power button, this incredible multi-stage process kicks off, and it's all orchestrated by the bootloader. It's way more than just an unsung hero, it's a living piece of programming history, really a testament to the ingenuity it took to build our digital world from a complete blank slate.
It truly is the invisible engine of your digital world, just working perfectly in the background every single day. And that kind of leaves us with a final thought. What other invisible pieces of software, just like the bootloader, are quietly making our modern lives possible? Something to think about. Thanks for tuning in.